Hello friends. So today we'll be learning about the resource allocation graph in Deadlocks. So it's called resource allocation graph in Deadlock. Okay, so what happens is, we'll try to analyze Deadlock with it. So let's say we have some processes P1, P2 up till Pn and some resources R1, R2 up till Rn which are required by those processes at some point of time, and let's say this is the P1. So we represent these processes by circles. Let's say this is P2, this is P3 and so on, and we represent the resources by rectangles. Let's say this is our R1, this is our R2, this is our R3, this is our R4. Okay, and if the resource has only one instance, then we put one dot inside it, something like this. If it has more than one instance, let's say R4 has 3 instances, then we put 3 dots inside it. Let's say there is a R5 which has 2 instances, so we put like 2 dots here. Got it? So let's say we have 2 conditions here. The process P1 can be requesting for a resource R1. So in that case, we draw an edge in this graph from the vertex P1 to the vertex R1. And similarly for some other processes, let's say P2 is requesting for R5, then we draw this edge. And let's say P3 is requesting for R4, then we draw this edge. Now let's say P2 is requesting for one more, let's say R3 as well. So something like that. So in this condition, after this request is satisfied, there will be a time when those resources will be allocated to those processes. For example, let's say R5 is allocated to P1 at the current moment. So it has two instances. Let's say one of the instances is allocated to P1 and the other of the instances is, let's say, given to P3. Okay. Now R4 has 3 instances. If one of the instances is given to R2, it can be given to the processes only. So let's say R4 has 3 instances, all of them are free, and we see that this edge comes. Then what we do is, R4 has 3 instances free right now, we can allocate it to the P3 right away. So we delete this edge from the graph because the request has been satisfied, and we assign this new edge, denoting that R4 is now assigned to P3. So this is the kind of modification we do in the resource allocation graph when a resource is allocated. Now we talk about this resource allocation graph. I think I mentioned this thing also, that the processes are denoted in circles and the resources are denoted in rectangles. If resource has more than one instance, they are denoted by dots inside the rectangles, and each of those instances can be allocated to some processes. Okay, and now R5 has 2 instances, but both of them are allocated to 2 processes, P1 and P3. So P2's request cannot be satisfied right now, so this edge will still remain in the graph. I hope this design is clear. Now we talk about this resource allocation graph in terms of a deadlock. A deadlock occurs when a process is holding a resource which is required by some other process. So something like this, and vice versa. So let's say we have two resources, both have one instance each, and P1 is requesting R1 and R2 is allocated to P1, and R1 is right now allocated to P2 and P2 is requesting R2. So this is a cycle, you can see in the graph, and in this cycle each of the resources present has exactly one instance. These both have one instance, so they don't have two instances such that one instance is allocated of R2 is allocated to P1 and the other can be given to P2 so that it can proceed and eventually it can release R1 which can be used by P1, which will break the deadlock eventually. This cannot happen. So right now P1 is waiting on R1 indefinitely and P2 is waiting on R2 indefinitely, while the vice versa processes have acquired them. So I hope you understood this concept of resource allocation graph. Hope you liked the video. Thank you, friends.